Fight!
So even the fastest computers today can't solve some of the much more simpler problems than the energy space will be tomorrow. You know, when you think about even some of today's quantum computers, they can process 18 quintillion things all simultaneously, a number that I didn't even realize existed, and they're only getting bigger and more robust. See you at ETS in Austin, Texas.
ETS24.
Good morning. Certainly great to join you this morning. You know, one of the things that Einstein is quoted to have said described quantum as spooky at a distance. That's not typically how I explain to folks quantum if I'm asked a question, but I think he had a point to it. I think really what he was saying is when you get down to that smallest particle, that things operate differently. And when they operate different than we expect, that's a little spooky, right? So I think he had a point to what he was saying. Now that's one of the questions I get asked quite a bit since we started getting into this space a little, is what is quantum? And I really don't think they're looking for an answer like it's spooky at a distance. I don't even think they're asking, for me to talk about qubits versus bits or behaviors like entanglement and superposition. I think they're really asking, why should I care? What is it that about this that I should care about? I think they should care because it is a paradigm-shifting technology. It will fundamentally change many of the things that we care about, right? And many different areas will impact how we deal with sensing. It'll impact quantum networks like we built. Security, our cybersecurity will be impacted tremendously by quantum technology, material science, and then computing. Perhaps computing is the place that is most visible, that impact. Today's quantum computers, or today's computers, period, under today's classical networks, they perform one instruction at a time. They're very linear in nature. They perform thousands of things a second. And yeah, you can put in multiple processors, but quantum computing performs many instructions all at the same instance. I had an opportunity a few months back to join a roundtable discussion that Senator Blackburn hosted about quantum, and there were some executives there from Microsoft, IBM, and IonQ, and the CEO from IonQ held up a little chipset about the size of my wallet and described that as their prototype for their 64-qubit computer, which they expect to have out in 25. And he started describing that as something that would perform 2 to the 64th instructions all at the same instant. And that's a big number. That's 18 quintillion. If you do that many things. So if you can do 18 quintillion instructions all at the same same instant, not second, and still, what does that change? What does that enable? And why should we care? The McKinsey study that comes out, Quantum Monitor, comes out in May of every year. Last year's, they projected that business value out of quantum technology would be over $1 trillion by 2035. Not that far away. And Boston Consulting Group did a similar study with similar results. They just added the fact that 90% of the value goes to the early adopters, the ones that engage first. And so what does it mean to our industry? You can go out and you can look and you can find companies all over the place that are partnering on this quantum technology. Airbus is working with IonQ. You see Hyundai, Volkswagen, a lot of businesses that are looking at quantum technology and trying to project what does it mean to our future. I think one of the most interesting projects that I've heard of they're working on is Airbus and IonQ are working on a little project that's seemingly simplistic because it's how do you optimize loading freight on an airplane? You know, kind of, I think it's pretty fitting too because it's really a Tetris problem, right? We had Hank Rogers here last year, but this is not a two-dimensional, it's a multi-dimensional Tetris problem, right? So it's not just length and width, it's depth, it's weight, it's lots of other characteristics, and we start trying to really optimize that. Today's processors are not really that great at it. And what they're hoping to do is be the one that owns the algorithm so that they process that solution every time a plane takes off, right? You know, a year or so ago, I was talking to, at the time, the CEO of US Express, which they've been bought since then, but at the time they were the 8th largest trucking company in the US. And he told me if we could truly optimize trucking, we would take half the trucks off the road. So if you think about those optimization problems, they're pretty simplistic compared to what our electric system and our grid is. Our grid is many times more complicated, and our future grid is even much more complicated than that. If you think about today, roughly you look at it, ask how many generators around the US, and it'll give you a number of around 25,000, about 13,000 utility scale, and about 12,000 others. You know, 10 years from now, will that number be 1 million or 2 million, or what will the number be as we multiply? So we can choose to continue to sub-optimize, which I think that we'll do some of that, but we need horsepower to really, truly optimize. If we take all those devices and we put them to working together, I love the description earlier about orchestration, DER orchestration, because I think that's really what it is. If we think about all these different devices, if they're not playing the same song, and you think about a bunch of musical instruments just playing something, it would be awful, right? So we think about when you could take them all and you could truly put them together, what impact it could be. So I think that's a fitting thing to leave with as we talk about today's theme around Imagine. So Jason, I think you were going to join, and I will kind of leave a few minutes for some questions too.
Thank you, David. If you do have a question, would you mind coming up to one of the mics here for David? But my first question was one that was fascinating and got my mind spinning and perfectly relates to all the talks about data and impacts. But if you could briefly just talk about how did EPB first start working on this quantum technology?
Yeah, how did we get working on it? Well, we actually kind of got there a little bit by accident. We had a great relationship with some of our national labs and with the Department of Energy, and was actually invited to join a project to look at how quantum technology could secure the electric grid. It was with Cubatech, a company, Oak Ridge National Lab, Lawrence Livermore, and the Department of Energy. Went on actually to win a R&D Top 100 award, and was the basis for an Edison Gold Award for Cubatech. But that got us really seeing possibilities and seeing what was capable and understanding that it needed partners like you and I. Like, we started seeing stuff they didn't see in the labs, like when the wind would blow, it would create errors. They didn't see that when they had a coil of fiber in the lab running. They needed real world places. So we started talking with Cubatech and started deciding, we need a place to start to test this technology, and that's when we decided to build the EPB quantum network.
So now turning to the risks, right? There's a lot of risks that we're talking about at this conference on AI. on the flip side, how should we be thinking about the risks when you introduce this much of transformational computing power into the industry?
Yeah, certainly risks. There are risks in everything we do. I think that's the case. A risk in not doing anything is a big risk. This quantum technology, the U.S. is not the only country that's working. All around the globe, folks are really investing heavily in quantum technology. China is one that is looking at it very heavily. And one of the things that comes about when you start seeing this technology, it also creates risk because it is a powerful technology. It will create cyber risk. But having the technology will help prevent those risks from materializing. From a business risk for us, just in this investment, we invested initially in the quantum network, feeling like that, okay, this will position us to take that next step. It'll position us to be able to be in a great position for the next step of grants or the next thing. And frankly, our initial investment, we've already received that back threefold just because of the enabling of taking a first step in an area where not many people were taking that first step.
So generation, transmission, distribution, all the way to the customer, if you had to pinpoint which area which would be impacted the most by such technology, give us your crystal ball.
I think they'll all be. I think this whole space of DER is a fascinating opportunity for all of us because the proliferation of devices that we're going to need to have working together to really optimize where we're going. In the short run, we've got enough load growth that we'll add devices and we can add them without worrying quite as much about how optimized they are because we're in a growth mode right now. So we'll be growing really fast, but if that growth mode slows 5, 10, 15 years from now, we should be positioned to really start to optimize those so that we can continue to manage the reliability, the resiliency, and the affordability of energy.
All right, thank you. Do we have any questions for David? Daniela.
Good morning. Thanks for that, David. My question is there one breakthrough or one policy change or one thing that you think needs to happen to accelerate the use of quantum technology as you envision it?
I think there's I don't know if there's a single breakthrough. I think creating the availability of these of quantum computers is certainly an access to those. They're available out on the cloud right now, but they're learning tools today because they're not robust at what's on the cloud enough that you can really take something that's totally transformative. I think within the next year or two, when you see processors like the one I described that IonQ is putting out in 25 and their next generation, when you start seeing folks that are working now towards understanding how do I program these and how do I think differently, along with the development, it's the collision of those two that I believe will really enable that. And I don't know, I don't have a crystal ball to know when it would. I think we'll see the aha moment in quantum just like we did with ChatGPT. And I don't know, for some reason, it feels like that's within the next couple of years to me, but it may be a little further off, it may not be. But it really is a collision of that, the technology of the processing power improving and the errors correction, along with us learning how to truly program these new technologies.
John?
Thank you. So the International Energy Administration is projecting that data center electricity use is going to hit 1,000 terawatt hours in 2 years. What's quantum going to do to that? I can see how it might fix it and optimize things at one level, but is the energy efficiency of this improving?
Yeah, actually, I know You know, I certainly won't claim to be the one with a crystal ball, so I'll tell you that this is a projection that I see, is that I think you'll be able to do more processing with quantum technology with the same amount of energy than you can with today's classical computers with more energy. So I think even though you'll be able to do more, I think you'll be able to do it with the same energy demands that you use classical computing with today. 'Cause we're still trying to do the things that classical computers are not really great for. And so as we start figuring out where classical computing really does work best, and we optimize around that, and we start figuring out where quantum computing works best, I think we will optimize the energy consumption of those. You know, one of the things that's, and there's multiple technology, you hear a lot about the ones that you see there, the gold chandeliers that look like and have to be cooled down to this 0 degree Kelvin. That's not all the technology out there. There are technologies out there now that you can put in a standard rack with the standard data center temperatures. So multiple developments in technology. And overall, my expectation was we would use less energy for more processing power.
Well, thank you, David. I'll steal the last question here. What is your secret to keeping that imaginative spirit to continue to push the industry forward?
Oh, I don't know if there's any secret to having I mean, we're in such a fantastic industry, I believe, at a fantastic time to be in this industry where you see this collision of technology, of need, of load growth, of decarbonization, and what a great place for us all to get a chance to create that future.
Thank you very much.
Thank you, Jason.